Hello everyone, in this lecture we will be presented the principle of food preservation, also hard-tool application for some agricultural preserved products. Now let's present briefly the content of this lecture, especially for the preservation of agricultural products through application of hard-tool technology, which will be the juice and fruit products, meat products, poultry products, fish products, and dairy products. As we have mentioned in previous lecture, the application of hard-tool technology is found to be successfully used for different agricultural products, and for this is increasing worldwide. And in fact, the proper application of combined methods can give stable products, also prevents the undesired side effects of each individual treatments. Furthermore, it can save energy and can be lower the required concentration of added preservatives. Also, hard-tool technology is found successful for ready-to-eat products without significant deterioration in sensory and nutritional quality of the processed products. Some examples of hard-tool application are propionic or sorbic acids, which can be added in effective amounts and may have an inferior flavor. Other application may be heat treatments such as sterilization and sterilized in cans heated at 116 Celsius degree may become very hard, brittle and brown. Also, recently gamma radiation may be used to preserve the food products by at 10 kg. For illustrating the success of a hard-tool combination, we can give an example for cereal products, for which is found that incorporation of sorbic acid along with citric acid, salt and sugar in the concentration of 0.2%, 2.5% and 3% respectively is effective in reducing the concentration of sorbic acid into 0.2%. This is for on wet floor basis. And for prolonging the shelf life of cereal products at ambient temperature, the adjustment of a lower water activity became necessary and could be achieved through a combination of sorbic acid in a concentration 0.1%, calcium propionate in concentration 0.3%, propylene glycol in concentration from 3%, polyethylene packaging as the most effective in arresting spoilage in partially baked products. An important food products category are juices and other fruit products, which can be preserved through application of hard-tool technology, and the most combined hard-tool factors are the low pH, depression of water activity, solute addition, commonly are used sugars, chemical preservatives, and the most important hard-tool factor is the thermal treatment. In fact, all these factors represent a hard-tool for the growth of most bacteria except those resistant to acidity like lactic, acetic and butyric acid bacteria. And these products generally for each hard-tool factor have an interval of effectiveness, and a low pH can be considered for these products to be in the range 2.3 till 5. High redox potential as a value or is in the interval plus 100 to 400 millivolt, have a high water activity, have a low content of vitamin B. As for the consideration of microbial spoilage of food products, can be said that fruit concentrates, pulps, jellies, jams, and dried products are often spoiled by osmophilic gas and xerophilic molds. In fact, the molds are few in numbers on the surface of fresh fruits, but after harvesting become important pathogens and spoilage factors. As for the microbial spoilage, can be said the molds are usually found in the most fruit products as a result of primary contamination of the fruit and often result in rotting. As for the yeasts are usually responsible for the characteristic fermentations and of flavor, mainly in crushed products, under pasteurized juices, and soft drinks. In fact, fruits have an inherent acidity and can help in protecting against bacterial invasion the various organic acids which are found in fruits. But fruit juices and other fruit products may be easily spoiled as a result of contamination due to high water activity, which allows microbial growth. Fruit juices in fact provide an especially good medium for growth of fungi, and the use of preservative is a good preventive measure against forming mycotoxin by fungi. In fact, the use of preservatives is justified in processing of many fruit products, since the high temperatures required to kill some spoilage microorganisms cause flavor changes, product discoloration, and loss of nutrients. But refrigerating and freezing extend their shelf life and do not stop the spoilage and aesthetic changes. Addition of preservatives, even permitted and harmless, represent a chemical method for food preservation and in fact is very applicable for preservation of fruit juices and related products such as pulps, concentrates, fruit nectars, and soft drinks. The combination of several preservatives with one another enhance their reaction against microorganisms and broaden the spectrum of their activity. The combined effect of two or more preservatives could be additive, arithmetic sum of the individual effects of each preservative, could be synergetic, which is greater than arithmetic sum of the individual effects, or could be antagonistic, which is smaller than arithmetic sum of the individual effects or that of the sole preservative. A beneficial effect is obtained by combining salts of benzoic and sorbic acid with sodium sulfate. Combination of preservative with pasteurization reduces F values or lowers the temperature required to kill microorganisms. In fact, for fruit products, the combination of ultra-low pasteurization and addition of low doses of potassium sorbate or sodium benzoate in the concentration 0.05% guarantees stable products. And the benefits of such combinations are evident in good nutritional and sensory quality, reduced energy costs, and lower doses of preservatives. The combination of preservation with refrigeration has a synergic and destructive effects on yeast and mold, spoiling fruit juice, concentrate pulps, and pastas, providing stable products. The combined effect of potassium sorbate and sodium benzoate with refrigeration is, for instance, increases with the concentration of added preservative and inversely with the temperature reduction. So the same effect can be obtained with a lower and healthier concentration at 4 Celsius degree as with a higher concentration at 0 Celsius degree. Another combination of preservative is with drying and is recommended in pretreatments. Light color fruits are treated with sulfur dioxide combined with low concentrations in the range of 0.01% to 0.02% of sorbic and benzoic acid in order to intensify the fungicidal action and prevent oxidative reaction, enzymatic and non-enzymatic browning, also for improving the color and minimize the vitamin losses. Intermediate moisture foods on fruit basis with a greater than 0.85 water activity, support the growth of molds and the yeast. Another combination of preservatives is bicarbonating and is common and utilized in soft drink production. Carbon dioxide itself does not kill yeast and molds, at least not in short term. In order to extend the shelf life of soft drink and minimize their spoilage, it's recommended the combination of 0.1% of equal parts of potassium sorbate and sodium benzoate with 6 grams carbon dioxide per liter. This was the end of this lection. When you have the opportunity to learn about application of hardle technology for preservation of important agricultural products such as juices and fruit products, meat and poultry products, fish products, and dairy products. Thank you once again, and looking forward to meet you in the next lection.